In this video, I will talk about Richmyer two-step Lex Van method. Lex Van method is a good method, but there are certain limitations in terms of solution. So what Richmyer did, he he took a predictor step, or I should say he introduced a predictor corrector formula. There is a predictor step, then we have a corrector step. Suppose we have a conservation law. F of u is a flux, F is a flux. The predictor step would be, in this case, the step 1 is the predictor step. Is un plus 1/2 j plus 1/2 is equal to 1 by 2 un j plus un j plus 1 plus delta t by 2 delta x f n j minus f n j plus 1. So basically this is the u, which is called a predictor step. You can see that the right hand side is obtained at j plus 1/2 and n plus 1/2. Suppose we have j and this is j plus 1. So it means that we calculate u in predictor step at j plus 1/2, and also if we have, for example, this is Tn and this is Tn plus 1, so the center of that these 2 points is is n plus 1/2, Tn plus 1/2. So we calculate this value, the right hand side, at the center of x spacing and the center of y spacing, which is time level. This is the, as you may see that this is Lex Friedrichs method. Lex Friedrichs method. It is not Lex Van Roff, it is Lex Friedrichs method. This is called actually a Lex step, or without dash. Okay, now the method is not finished yet. The next one is the second phase is corrector step. Corrector step. In corrector step, we get the answer. We get the answer at un plus 1 j un j minus delta t by delta x, and we have f n plus 1/2 j plus 1 half minus f n plus 1 half and j minus 1 half. And remember that we have Fn plus 1 half, which is a flux. J plus 1 half is equal to F u n plus 1 half and j plus 1 half. And you can see that this un plus 1 half, j plus 1 half can be obtained from this formula. Suppose we have a flux. Suppose we have a flux f. F of u is equal to maybe a u, then f n plus 1 half j plus 1 half will be equal to a u n plus 1 half j plus 1 half, and that value, this value that we can obtain from here. Similarly, we can obtain n plus 1 half j minus 1 half. So what we do, we replace j with j minus 1. So we get j minus 1 half. So in that case, that u will be for j is equal to j minus 1. We have un plus 1 half j minus 1 by 2. Since the time level remains the same, we want to calculate both the fluxes at this time level, which is n plus 1 half. So we have 1 by 2 un j minus 1 plus un j plus delta t by 2 delta x f n j minus 1 minus f n j. So that will be the flux on j minus 1 half. Suppose we have j plus 1, we have j minus 1. This is j plus 1 half. This is j minus 1 half. So we calculate j plus 1 half at n plus 1 half, which this is actually a cell. This is over cell. So we calculate fn plus 1 half j plus 1 half, and j plus 1 half can be obtained from the values of j and j plus 1. You can see that there is j and j plus 1 half. And similarly, when we have fn plus 1 half and j minus 1 half, then we need j and j minus 1. Value of j and j minus 1, but the flux is flux will be j and j minus 1. Okay, that's what we have over here. Okay, so this was all about the uh, Richmyer method. Thank you for watching.